And good morning. Good morning, everyone. Happy Wednesday. Trying to dig out OBS from the background. We're going to get going. Still working on getting data passing back all the way through. We're going to have data going out to Twitch, but not coming all the way back. So we're going to be working on that today. So this is exactly where we left off. Haven't touched this since yesterday. I did try to update some Rust yesterday. Just the Rust up stuff. We're going to add some logging for data coming back. So let's start in the client, and where we are receiving data, we will log how much data that we received. Does the client have a logger? It must. It does. Hey, good morning. Morning, everyone. How you doing? Stupak, 62. Welcome, Raiders. Morning, Rex Roof. Thank you for the raid. Good morning. And just so that here, let's catch everybody up. All right, this is our. Let's go back a little bit. All right, this is what we're working on. Okay, so on the far left, you have OBS, and then you have basically what we're working on here. The Stitch client on the right and the Stitch server. So OBS is going to connect to this Rtmp server, and we're going to basically tunnel that through an unreliable internet connection, right? I'm on Starlink. Then we have our Rtmp client, which will then connect to Twitch on the other side. The client here will add some sort of delay, like a 5-second delay. And that should smooth out the majority of the bumps I have with Starlink. Because in OBS, I am trying to avoid these dropped frames due to the network. So we have the connection working in this direction, and we've got some code set up. We just need to verify that the data is coming back the other way. So we're going to add some logging. Where will the server run? This one here, the server is going to be on localhost, localhost. And this one over here on the right, the client that's going to be connecting to Twitch will be on Linode. So we have Rtmp crate that can process, it can parse the basic header for Rtmp. Rtmp has like 2 layers of headers, right? And it has a basic header, which tells you what's going to follow. And then it's got the message header. And we've got parsers for each one of those. But the body of this, we're not parsing into that because we don't need to for this to work. So let's add some logging. We're on the client side, the one that's closest to Twitch, that's in this file here. This is our Twitch client, basically. We send proxied packets to it, and we receive instructions back from it. And this would be something like setting the channel size or things like that. We can actually see a little bit of that in Wireshark. Let's see, are you still awake, Wireshark? It is. And this chunk size right here, this one should have come back yesterday. We're picking up from where we left off yesterday. And you can see that there's the format basically at the top. So you have the basic header and then the message header. The message header starts at about the timestamp. No, yeah, this section here. So we do not parse our previous timestamp, and then we take the packets and we put it in this channel. It's an unbounded channel because we want kind of a spongy buffer. Okay, so that looks like it's wired up. Let's log this. Log. Let's see, debug. Received packet. Let's see. Let's say client. We'll just list the timestamp. All right, that should be enough there. Now we need to go back to the, let's pull up the infographic here. Client server. I call it server because it's like a server over here. It's accepting connections. And this one over here on the right is a client because it is going out and making connections. All right. So in this case, we have sendTX and sendRx. RX should be the ones that are coming back through. And we receive a packet and write it out. We write how many bytes there were and then the bytes. All right. Log, debug, server, sending blank bytes. We might want to also include how many bytes were on the other one, just so we can match them up. Okay. Now that should be both on the right side of the graphic. Now let's debug here and then here. So now for the third one, this is going to be server. Server main is set up a little different. It was the first one we did. The patterns are slightly different. Still have two channels. So our client, which is the one that connects to the client. We have client write and client read. It's going to be inside of client read. So the first thing we do is we read how many bytes we should read. Create bytes mutable with that. Read exactly that many bytes. All right, now for the server, and then we'll get into a test. Or is that server write? All right, that should be everything. So let's get it compiled and running. Oh, I was playing with ADB stuff. Actually, I'm trying to get Android reinstalled on this device. Remove some of the red lines. There we go. That's the client on the right. Now let's get the server running. And this is set up such that when OBS connects to the server will then connect to the client, and the client will then connect to Twitch. So it doesn't actually link all together until it starts receiving data. Part of this is because we don't want to just sit there with an open connection to Twitch, not doing anything, because then they might close it and then we'd have to redo it again, and that would just be annoying. It would be bad for, I don't know, it's just like a bad client, you know? So now we have to launch OBS. Okay. Before I do that, I'm actually going to reset a stream key. Good. And where is, here's OBS. Launch anyways. I wanted to check, does it actually drop the stream key in this? Doesn't look like it, so because in Stitch, we're streaming to localhost with some random key. Now, I do expect this to fail. I'm going to be recording this at the same time. I'm going to restart that. And you can do it. You can do it. Oh, Wireshark. Wireshark's buffer is there. Goodbye, Wireshark. Now, what I would love to do is to be able to filter this early on, because we're going to connect to that Twitch server. But it does not like this filter. And I haven't figured out how to do this correctly. Why is Wireshark being slow? Yeah, we don't know. Give it a host. Now, I don't know if that's going to, we'll see. Hopefully that'll filter it enough that Wireshark doesn't die, because Wireshark is also going to have to filter through all of the traffic that we're using right now, which is a lot of traffic. Let's try that. I don't know if it's going to capture enough though. Okay, we should still have everything sitting there and waiting. Great. Now start streaming. Go. All right, so we sent some data out. We connected, sent some data. Yeah, it's like it just didn't get anything back. Where are we at, Wireshark? Where are we at? Oh, maybe we did get enough. Okay, let's stop it. We have a little handshake. This should be us talking to localhost, is it? No, this is us talking to Twitch. Okay, that one there. There they are sending data back to us. Okay, and here's C2, which is the last piece, because a couple seconds later we send the S's. C0, C1. They send S0, 1, and 2. We send C2, and then nothing. There was nothing after that. Let's follow the TCP stream. We want to see this as a hex dump, please. So we send data first, right? C0 is basically this section here with a couple of timestamps and then a lot of random data. It's truly random. This is interesting. What's this? Oh, they respond. We have timestamp their data. So this is C0, C1, or S0 and S1. They're sending us information back. Oh, maybe these are just different packets because it wasn't in the same packet. Here they are echoing us. Then we send our data back to them, echoing them. Is it the same? Sending the right data to them. It's nice that we're both using 0 as our epoch because it just makes it so easy to spot these. Yeah, we're not sending the right data. They just start paying attention to us at the end. Oh, Hmm. Let's check on our handshake in the client. Not the server, client, handshake here. So in the RTMP handshake, you start out with C0, which is just the number 3. 0, 1, and 2, or 1 and 2 were deprecated, and the rest of the numbers were just reserved for future use. Then we have our time and some random data. Now, this should be enough to fill 1537. 1537 is the correct number of bytes. We have 1537 minus 1 minus 4 minus 4. That's 1528. 1528 divided by 4 should be 382. Yes. So that should be enough random data to finish filling out C1. So we send both of those, and that should be everything, which I think works because we see that getting replied, don't we? We see S0 and 1 getting responded here. Now S2 should be the data that we sent in S1. Okay, so 6642. Yeah, 6642 here. All right, now we presume that Twitch has implemented this correctly because we're talking over it right now. Okay, so if that's all right, and they responded to us, then let's check our response to them. C2 should be the same data that they sent earlier. This doesn't seem like it's enough data. Oh, there we go. We can click into it. Actually, we're going to change radio stations. Stations surprise me. I don't know. This one's kind of too chill. This could be fun. A little metal. That they sent. Now let's find the data that they sent. Here. That one versus this one. Now we want to see this. Is this the same? I mean, here it is, 18A7D. But what is this little blip here? Oh, that's how much time. Yeah, that's the time it took us to respond. But should that be 1, 2, should that be 3? So we read S0 and S1, validate S1, send C2. Yeah, here, we just put the elapsed time, C2.data. Morning, Turbo Dave. I don't know, sometimes it's just, I can listen to metal, and I used to, oh goodness, I spent many years programming to Black Sabbath and some some hard metal. Um, I don't know, it's not really streaming music for me. Just isn't. Actually, this looks like it's correct. Right. So minus the 3, we have 2 timestamps basically. Then we have 18 A7D0. Elapsed, which is 001389. Sure. That should be about 5 seconds. And then we send them the data that they sent us, which is 18A7. Yeah, that looks fine. But what about the end of it? Uh, Actually, we want the end of the first section. Should be about halfway. Okay, so it ends in 2E, 7B2E. That looks right. So why didn't we get more data from them? Was the handshake too slow? And yesterday we did get more. The day before we got a little bit more data. Maybe Wireshark just didn't capture it? Hmm, let's try again. I don't quite believe it. All right, close up some of these. Now back to OBS, wherever it is, this tile. Okay, here we go. Okay, click Start Now. Starting Handshake. Forwarding packet with timestamp 0. Oh, 18 bytes send. That should have been it. 18 bytes. It came all the way back. But it still thinks it's connecting. What else does it need? Yeah. Okay, so this time we got the RTMP chunk size, which is great. Good, good. All right, connection closed. Got our FinX. 18 bytes sent. Is that the last one? No, not client server. Server main. Server sent blank bytes. No, it's not. All right, what about forwarding packet with timestamp 0? See, we're not even getting this. Okay, I think we're just not reading data from Twitch for some reason. Because that data, forwarding packet, this should be on the client. See, we want to see this one. Client received bytes. Is it getting stuck in here? It should be able to parse this header. It's format 0. And I think I put panics in there for the places where it wasn't implemented. So if we reached one of those spaces, it should have blown up. This is a little bit more country than blues. We've got the blues. Oh, I see. And look, a harmonica. That's interesting. How much blues is in country? I bet quite a bit. Yeah. Like some of yeah. I'm guessing that it's stopping in here somewhere. So let's add some trace messaging. All right, which one? Reading the message header. Oh, net doesn't use log. Okay, now let's get this built. Here, we'll thumbs up some of this. That previous one I wanted a thumbs up too. And that's blocking, that's okay. About to read basic header. And that's it. That's it. See, we're setting the chunk size. Hmm. Ah, I've so those of you that don't know, I have goats, and we have a little goat emergency. So I'm going to take a 10-minute break. Who knows? It might actually be 15. So, all right, give me 15 minutes. A little goat jumped into the. Okay. Little goat emergency there. Yeah, the goats and their shenanigans. Precisely, Turbo Dave. Precisely. I don't know. The goat's got to be like 3 weeks old, and it jumped into the water. Couldn't get out, and of course, goats don't get each other out, so they're much more of a prey animal. One of them doesn't look healthy. They're running. So it's inside. We've got it under a hair dryer. And all we have on this is about to read basic header. So we didn't get anything back. Let's try it with a shorter delay. Let's say a delay of 0. Just gonna do this with OBS. I'm gonna ignore Wireshark for a second. Okay. About to read basic header. Okay, that just went through so quick, but nothing. I feel like they just don't want to talk to us, you know? Earlier on in our tests, before we had the client, we just had the server passing data through, and that was working. Let's add some tests. I'm suspecting that it's um, I don't know, client. I think it's a handshake, but I'm not certain. Oh, I know. Let's just reverse the polarity and have the client talking to the server because the server is acting like an RTMP client or RTMP server. So here we're going to listen on 1935 and we're going to connect to something. And over here, we're going to listen on something else that we will connect to with netcat 40,000. And we're going to connect to 127.0.0.1, 1935. There we go. All right, now all we have to do is connect to 40,000. All right, 40,000. All right, looks like I want something else. That didn't. That didn't run. Okay, let's just connect again, and we'll give it some zeros. Well, that's not really zero. That's like ASCII 0. No, we don't. Let's see. No, do we have a hex editor? No. No, I actually need a. All right, let's do this in two phases. Because yeah, we'll connect to localhost on 45454, but we will have OBS write that out to a file, not OBS, but Netcat write that out to a file. CD to stitch. While we're thinking about it, there, netcat -l 45454. We will pipe that to test.bin. Okay, then this will connect. We'll hit this with OBS, save the output to file. There we go. Netcat should have the data now. Let's go ahead and kill that. That should stop Netcat. Now we have 26 bytes in test.bin. All right, so now come back over here. We're going to set this up to connect to the server, and we will feed it data on 40,000. Then this, it's not going to connect to anything, but that's okay. We just want to see that the client is doing the right thing. So netcat dash, no, 127001, 40,000, bring in test.bin. Okay. Unexpected end of file. Yeah, it didn't last long enough. It didn't even get to the handshake. Let's create a larger file with many of those in it. So cat test.bin, we will append it to big test.bin. Do that a couple times. Big test.bin. Does that not work? That might be big enough. All right, start it again. All right, that's not working. Um, let's do it the right way. Let's write a test. Okay, we're gonna test out Handshake here. Test module test. Handshake test. Now, one of the things that we wanted to do before was update Handshake so that it took the reader and the writer and not a TCP stream. So let's do that. That'll make it easier to test. Go ahead and move the split up. And we'll give it the read and the write. We'll have R, which is a async read ext, sun pin, and a write. Oh, no ext on that. Oh, this is kind of a sad song. I like the voice. Voice good. Goes along with our test writing. All right, now here, write all, read exact, write, read. Okay, now let's go simulate the server and the test. Oh, let's see, where do we have some tests currently? I think in Rtmp, basic header. Yeah, there we go. Just we were avoiding pulling in the larger dependencies, so we're not using the macros. All right, now we write our tests in here. And OBS, stop bouncing. It's bouncing on the other screen. Okay. And how do we test this? Basically, we have to, well, let's start with calling the function. Read, write, and delay. We'll just give that a 5. Await. Unwrap. Okay. Now we need some tests, some assertions. So we have to be able to give it something that I can write into and something that I can read from. We are going to, let's just do this nice and easy. S0, 1, and 2 is here. We just want to copy these bytes. Copy as hex dump, sure. I'm going to paste these in here. That is not it. That's not S0, 1, and 2. That should be much, much larger. Then S1 needs to be a little different, doesn't it? Ooh, it does. Now, what could we use instead? We could use a Unix socket. That would work. We'd also use a cursor and a couple of vectors. But that, mm. All right. Creates an unnamed pair of connected sockets. Okay, well, we'll basically have two pair. Let's call this A and B. Then we need to split these up. A read, A write, and to split. Okay, same thing. Let B read, B write. All right, now what are we going to give to this? We're going to give it a read and b write. Then we will give the tester the other thing. Make those mutable. They will all need to be mutable. All right, now in this case, we're just going to simulate kind of the expected values. Now, let's do this quick. This is b read, read u8. That needs to be that. Okay. The next thing it's going to be is two U32s. These will both be 0. What is that, 1528? There we go. We'll await that, then we will expect it, or unwrap. We're in unit test land. That needs to be mutable. Okay, that should be the first portion, but then we have to respond. Same thing, we give it a 3. Oh my goodness, unwrap, there we go. Then we give it that, a bunch of random data, which we're just gonna give it all zeros. I guess we could give it all ones. And let's rename this. This is C1 data.